Welcome to the Explainer. You know, our world is just full of chance, from a simple coin toss to the wild swings of the stock market. Today, we're going to grab that uncertainty and put a number on it. Let's make sense of probability together. I mean, think about it. We deal with uncertainty all the time. But what if we could actually measure it? What if that feeling of maybe could be pinned down with a precise mathematical value? Well, that is the whole idea behind probability. So, here's our game plan. We'll start with the big idea of how to measure maybe. Then we'll learn the special language of chance. After that, we'll sort through different kinds of possibilities, figure out how to actually calculate the odds, and finally get into the rules of the game. All right, let's dive right in. First things first, what is probability? Let's get a really solid, simple definition.
Okay, at its heart, it's really just a scale that goes from 0 to 1. That's it. 0 means something is totally impossible, like a fish riding a bicycle. And 1 means it's an absolute certainty. The sun's going to rise tomorrow. Every single maybe in our lives falls somewhere on that line in between.
Now, to really get good at this, we have to learn to speak the language. Yep, probability has its own vocabulary, and it's what lets us talk about chance with total precision. It all starts with something called a random experiment. This is just any action where you don't know for sure what's going to happen. It could be rolling a die, pulling a card from a deck, or even just looking outside to see if it's going to rain. It's the thing we're watching. Next up, we have the sample space. I want you to think of this as the complete map of everything that could possibly happen. For any experiment, this is the list of every single outcome. If something isn't in the sample space, well then it's just not possible. So if the sample space is the entire map, an event is like the destination we're actually interested in. It's the specific outcome, or maybe a group of outcomes, that we want to figure out the odds for. Okay, so not all events are created equal. It turns out we can sort them into different types, and that really helps us get a handle on how they relate to each other. So the first way to sort them is just by size. A simple event is just one single specific outcome, like getting exactly heads on 2 coin flips. But a compound event is a whole collection of outcomes, like getting at least 1 head. That actually covers 3 different possibilities, right? And this is really important. We have 2 key relationships here. Mutually exclusive events are things that just can't happen together. Think about it. When you roll a die, you can't get an even number and an odd number on the same roll. Then you have exhaustive events, which cover all the bases. Together, they make up the entire sample space. One of them has to happen. Okay, we've got the concepts, we've got the vocabulary. Now it's time for the main event. Let's actually turn all this into a number. This is what's called the classical definition, and honestly, it's just beautiful in its simplicity. All you do is count up the number of ways your specific event can happen, and then you divide that by the total number of things that could possibly happen. Now, there is one huge catch. This only works when every single outcome is equally likely. Let's put this formula to work. So, first step, we lay out the entire sample space. What are all the possibilities? Well, with 3 kids, there are 8 possible combinations. Step 2, we hunt for the outcomes we actually care about. In this case, the ones with exactly 1 girl. And we find there are 3 of them. So for the final step, we just do the math. 3 favorable outcomes divided by 8 total outcomes, and boom, we get a probability of 3/8. In the real world, events don't usually happen in a vacuum. So to tackle more complex, interesting problems, we need some rules for how probabilities can be combined and how they interact with each other. And this right here is the super powerful addition rule. It lets us figure out the probability of event A or event B happening. Now, you might think you just add their probabilities together and you're close, but we have to subtract the probability of them both happening because otherwise we'd be double counting that overlap. Makes sense, right? Okay, let's look at a practical example. Imagine we're at a roadblock. We've got data. We know the probability a random truck has faulty brakes. We know the probability it has worn tires. And we also know the probability that it has at least one of those 2 problems. So here's the puzzle. With those 3 pieces of information, can we use our addition rule to work backwards and figure out the probability of the overlap, the chance that a truck has both problems at the same time?
We absolutely can. All we have to do is rearrange that formula a little bit. We add the individual probabilities for brakes and tires, and then we subtract the probability for brakes or tires. What that leaves us with is 0.09. So there's a 9% chance that a truck that gets stopped has both faulty brakes and worn tires. Pretty cool.
So let's just pull this all together for a second. We started with a really simple idea, a scale from 0 to 1. Then we built a language to talk about chance, and that let us create a simple formula to calculate it. And finally, we saw how having rules lets us combine different probabilities to solve much more complex real-world problems.
Look, this whole framework isn't just about math. It's really a tool for thinking more clearly about risk, for making smarter decisions, and for just understanding the world around you a little bit better. So the real question is, now that you know the logic of chance, what are the odds you're going to use it? Thanks for joining us.